United States of America, the best country in the world. In many fields, economy, science, and military, etc. And Donald Trump. Oh sorry, this by Millikan, Robert Andrews Millikan, born March 22, 1868, Illinois, and rest in peace on December 19, 1953, California. A physicist, a professor at the University of Chicago, honored with a Nobel Prize in 1923 for his study of the elementary electronic charge and the photoelectric effect. Okay, what an ideal biography. What was he doing? He measured the electric charge of a single electron in 1909 with the help of his doctoral student, Harvey Fletcher, at the University of Chicago. Okay, why he did the experiment was he wanted to prove to the world that I'm the best physicist, not this guy Albert Einstein. He wanted to prove the existence of subatomic particles, especially the electron, which was first theorized by J.J. Thomson in 1897, and was not universally accepted. Also, he could say that charge can be quantized. He uses some formulas in physics law to work out ways to measure the tiny charge, and also how the experiment is constructed. When the particle is suspended in the electric field, two forces acting on the particle, which are gravitational force and electric field force, balanced. Therefore, he said that Fg equals Fe. Fg equals to the particle's mass times 9.81, and Fe equals electric field times charge, Eq, which equals to voltage times charge divided by distance between the plates. Rearrange the formula, he can calculate Q, which equals to M times 9.81 times distance divided by voltage. To calculate M, he measured the radius of the oil drop to determine its mass. With D is fixed, he changes the voltage applied in the electric field to suspend the drop. He could work out Q. Wait for a minute. Why was oil used, not water, or any liquid? Great question. At the first attempt, he used water droplets, but quickly found that the atomized water droplets would evaporate too quickly under the heat of light to get accurate measurements. On the other hand, oil does not evaporate that quickly, and it is still liquid enough to be atomized and run through the apparatus. Fletcher and he suspended tiny charged droplets of oil between two metal electrodes, the process of balancing downward gravitational force with upward drag and electric forces. They created a uniform electric field by applying the voltage across a parallel pair of horizontal metal plates. Then a ring of insulating material was used to hold the plates apart. 4 holes were cut into the ring, 3 for light, and another to allow viewing through a microscope. They made a small hole to allow the oil droplet to go in. The space between the plates is ionized by X-ray to charge the oil droplets. Above the plates is a chamber where a fine mist of oil was sprayed by the atomizer. The atomizer sprays oil to the chamber. Some of the droplets pass through the hole. While they pass the hole, the droplets are charged with the X-ray source. The voltage is applied to the plates, creating the electric field between them. The electric force impacts on the droplets, encountering the gravitational force. Millikan alters the voltage until some of the droplets balance. Through the observation, he can measure each droplet's radius and the voltage needed to balance it, and use the formula to calculate the charge of each droplet. The relationship between the oil droplet's weight and the charge is graphed as follows. That is such a complicated process to find out the charge. Yes, by making a table of values, he found the charge of the electron is the factor of the product of mass and voltage applied. And he found that the size of charge is 1.59 to 1019 coulombs within 1% correction of today's accepted value. What about the accuracy of this experiment, sir? Okay, there is also viscosity force acting on the oil droplet, dragging the droplet when it rises or drops, but in high school level, I just gonna leave it to its very basic principle. What a meaningful discovery of the 20th century. Give him a big applause.